So in our previous videos, we looked at different ways to solve systems, and we're going to add a new way in this video. We're going to add what's called the substitution method. We're going to take one equation and basically place it in the other one. So if you notice in this example, 3x minus y equals negative 2. The second equation literally says y equals 5x. So what we're going to say is if y is 5x, that y that's right there is also 5x. So what we would have is 3x minus, replacing y, and you always want to put it in parentheses so that you know what to do with the things around it. You would have 3x minus 5x equals negative 2. So 3x minus a positive 5x. So 3x minus 5x is negative 2x equals negative 2. We divide by negative 2, and what we get is that x equals positive 1. Now what's nice about the way this is set up is it then says y equals 5x. So y equals 5 times x. Y equals 5 times 1. So y equals 5, and now we have the solution to our system. It is 1, 5. Here we've got just a little bit more work to do because our y equals equation's a little bit harder, a little bit more challenging, but we still want to put that in parentheses, and we're going to replace that y right there with negative 2x minus 1. So we'd have 3x plus 2 times our y, which is negative 2x minus 1, equals negative 3. And so we're going to solve this equation for x. So we need to distribute this plus 2. So far we'd have 3x. Positive 2 times negative 2 is actually negative 4x. Positive 2 times negative 1 is negative 2 equals negative 3. Combining our like terms, 3x and negative 4x makes negative 1x minus 2 equals negative 3. We add 2. Negative 1x equals negative 1. Divide by negative 1, and we get x equals positive 1. We can then take that x and plug it in to find y. Y equals negative 2 times x minus 1. Y equals negative 2 minus 1. So in this case, y is going to be negative 3. So our point, our solution is 1, negative 3. This one's very similar, except for instead of being a y equals equation, we have an x equals. So if x equals negative 3y plus 10, we're going to take that and we're going to plug it in for x. So we'd have 5. Plugging that equation in for x, we'd have negative 3y plus 10 plus 2y equals negative 2. And that's, again, plugging that x into the bottom equation. So let's solve this now for y. We can distribute this 5 in. Negative 15y plus 50 plus 2y equals negative 2. We can combine negative 15y and positive 2y. That's negative 13y plus 50 equals negative 2. We subtract 50. Negative 13y equals negative 52. Dividing by negative 13, y equals 4. So now we have y. We can bring that all the way back here and get x. X equals negative 3 times y plus 10. X equals negative 12 plus 10. So x equals negative 2. So our solution, x is negative 2, and y is positive 4. Okay, so last one, and the way this is set up, you could actually use elimination if you would like to. You don't have to, or you can use substitution. I would use substitution because what I notice is for this second equation, if I add y over, I'll get x equals y minus 1. That equation is the same as this one here. X minus y equals negative 1. So if x equals y minus 1, I'm actually going to take y minus 1, and I'm going to come all the way back here and plug it in for that x. So 2 times y minus 1 minus 3y equals negative 6. Distributing 2y minus 2 minus 3y equals negative 6. I can combine that 2y and negative 3y. It gives me negative 1y minus 2 equals negative 6. Adding 2. Negative 1y equals negative 4. We divide by negative 1. Y equals positive 4. Now I can take that, and since I have this x equals equation, and plug it in. X equals 4 minus 1, x equals 3. Our solution is x is 3 and y is 4. That is the point where those two lines would intersect. And interesting enough, if you wanted to do that with elimination, you could, and you would end up with the same answer.